So now let us study about the queues. Now queues are like, it follows the in stack, I said you, it follows the LIFO technique, right? The queues, this queues will follow first in first out, that is FIFO technique, right? First in first out, the person who comes first must leave first. So that is what the meaning. So queue, you can simply imagine like a bank queue that you and I have experienced. So there will be queue, and the person who comes first, he will get the service first, right? And he will go, and the next person will get the next service, like that. The person who comes first, he must get the first service. That is what queue will be used. So again, let me show you the code using linked list. So it takes this much length of code in order to create queue. That means pushing and popping out of queue. So there are some very few functions that you can use in queues. So those are like enqueue. So similarly, when we talked about stacks, we have discussed about push, right? Right, push means inserting the element. Similarly, in queues, we will call it as a enqueue, or you can call it as a push itself. There is no problem. Again, to delete the element, so which element you are deleting? You are deleting the first element. For example, let me take this queue, right? So you have inserted 10 first, then 20, then let's say 30, then 40. You have inserted like this. So if you pop, it means if you remove an element, this 10 will be removed first. So that is how queue will work. So as I said, there is very few functions that you can use for queues. So this is enqueue, means it is to enter the input into the queue. That is enqueue. And it is next one is dequeue, right? Dequeue is to remove the elements out of the queue. So or you can call it as a pop, no problem. So you can use size, you can use top, you can use empty. So these are the things that you can do. And this is a code for linked list. Using linked list, you are creating a queue. So this is a C++ program, and you have created a structure. Then again, enqueue, we need to enqueue 10, right? For enqueuing, you are using this big function here. So we can reduce this to a single line, right? For dequeue, you are using this much big function. After that, you need to display. So I am enqueuing 10, 20, 30, 40, 50, and I need to display. From starting element, that is from 10, I need to display, right? From starting element, I need to display. Then till 50, I need to display, right? And then if I pop, then I need to return the element which I have popped. And in this case, 10 will be popped because 10 is at the first, right? So if I run, I'll get 10, 20, 30, 40, 50, and deleted element is 10. And even if you print again, let me display this again, you will be not having this 10, you will be printing from 20 to 50. So let me show you that. So this is taking some time. So in STL, what we are going to do, this whole thing will be reduced to nearly 4 to 5 lines. So deleted element is 20, 30, 40, 50, because I have not given that cout here. That is what the mistake I have done. So let me give cout in line. So let me run. So I should get properly. Now for in STL, so you can see here 10 is not there because it is deleted. Now let me remove this code, right? Let me write this code using STL, and you will appreciate how good is this library. So for that, you need a library called queue, right? Just like stack used inbuilt you use that library stack, right? Similarly, you need to use queue library. After that, you need to push. How to push? Again, it is simple. First of all, you create a queue. How to create? queue of what type? In type. It can be of any type. Then queue. Queue dot push. You are pushing the element. Which element? Let me push 10. So queue dot. Let me push another element. Let me push 20. Next, I will push 30. So now I have pushed 3 elements, right? Now I need to pop. right? Or else let me check the topmost element. So q dot top will give you the topmost element. So if I run, so q dot top, so actually it is not there, q dot top is not there, but there is another library that is, so I missed just saying, so sorry for that. Front, so it will give you the frontmost element. In this case 10 is the frontmost element, right? You need to get 10. So top is not there in the queue because it is a queue, right? So stack will have top, not the queue. So I am getting what, 10. And to bring the last element, again it is simple. You can use q dot back, basic back. Let me see out end line. So if I run, I should get 30, right, for back. So after that you can check the size as well. So let me check the size. COUT q dot s size d size, then it should give me what, it should give me 3, because the size is what, 3. There are 3 elements. You can pop the elements as well. So let me show you after popping it. So you should get 10, 30 and 3. 10, 30 and 3. Finally it is executing. I don't know why this has become this much slow. Now I need to do what, I can use empty. So if this q dot empty, empty, so if it is not empty, then you print out the first element. So you can use that one. So front, so it will print you the first element. So that is how you can use empty. And for empty, let me print out print out q dot empty. That means it will return, if it is empty, then it will return what, it will return me 1. Since it is not empty, it will return me 0, because q is not empty. That is why I need to get 0 now. So after that I'm going to use pop function. Then after, so you are getting 0. Then, so let me write here what the functions that I'm using. So push, push push. Now here I used front. Here I will use back. Here I will use size. Here I can use empty, and I can even use pop. So let me pop some elements. So this is pop. So q dot pop, that's it. You will be popping what, you will be popping 10. So if I print the topmost element or front element, sorry, this front element, it should be printing you 20, not 10, because 10 has been popped. So you need to get 20 at last. So you are getting. So this is about queues. And next thing is, so let me, in this video itself, let me tell you, there is another type of queue, that is priority queue. Priority queue. For this also you have the inbuilt function. So what you are doing in this priority queue is, the elements that you are inserting, that is pushing into queue, right, that it will get sorted. That means the front element will be what, the front element will be, or you can say top element, right, top element will be the highest element, the greatest element. So it will give priority to the greatest element. So if you push 10, imagine you are pushing 10, 20 and 30. So finally what will be having in the priority queue is 30, so 20 and 10. So this is what it arranges in ascending order. So in order to create that, you don't need any extra library. This queue is required in order to create priority queue. So let me do priority queue, priority priority. Now, and how to create priority queue? Again, priority queue of what in type? Let me give the name as Q1 or priority queue PQ. Now, similarly, what you have done for queues, all of this thing are valid here. So you can push. So let me pq.push push. I'm pushing 10, right? pq.push. I'm pushing 20. But if you print the topmost element, for example, let me print if this pq and pq is not empty. If it is not empty, even not empty can be so not empty. You need to print out what? You need to print out the topmost element. That is pq dot top. So it will print what? It will print, actually it will print 20, not 10. So if I run, I should be getting 20 at last. Then other things that you can use here is the size. You can use normally size. You can use pop. So let me show you how, so 20 I'm getting. So finally let me use this size. So I need to input print the size of priority queue size. Let me give in line. Then let me pop some elements, right? After that, let me check the size again. PQ dot size. So you should be able to get for this cout you should be able to get 2. For this cout you should be able to get 1. So let me run. So you should be able to get height. Why is this much slow? So it is, you are getting 2 and 1. So this is about priority queue and queues. So thank you.